Welcome. Today we're going to look at lesson 10b on matrix multiplication. So we're going to find products of two matrices, and we're going to do it with a variety of methods. We're going to do them by hand first, and then we're going to look at how to do them on a TI graphing calculator. Desmos also has a matrix calculator, but it's in beta mode, and I haven't had a chance to really play around with it. But that's another tool if you wanted to spend some time trying that out. So in order to actually multiply two matrices, you have to have the first matrix be dimensions. I'm just going to zoom in a little bit. The dimensions aren't necessarily the same, but if I have an m by n matrix, that can be multiplied by an n by p matrix. So it's that the number of columns in the first one must match the rows in the second one. Okay, otherwise the matrix is not defined. So if I had something that was 1, 2, 4, a 2 by 2, the one it's multiplying must be, actually, let's make it a 2 by 3. 2 rows, 3 columns. So then what I'm multiplying must be 3 by something. It doesn't really matter what the, whoa, sorry about that. It doesn't really matter what the columns are, but this number of columns has to match this number of rows. So otherwise the multiplication is not defined. Let's take a look at what that looks like. We're going to do something that I call run and dive. So first of all, my dimensions on this first one is a 2 by 3. My dimensions on this one is a 3 by 2. Notice that this 3 and this 3 match. That's how I know my multiplication is going to work. And furthermore, my answer will be a 2 by 2. So let's see what this run and dive. And you run and then dive off the diving board. So I'm going to run across this first column, first row, and dive down this first column in the second matrix. Okay. So when I do this multiplication, I'm going to take 1 and multiply it by 7. And then I'm going to add 2 times 8. And I'm going to add 3 times 9. And so because I ran in the first row and the first column of the second one, first row in the first one, first column in the second matrix, that's going in the first row, first column of my answer. Okay. Now I'm going to run and dive again. I'm going to run across that first row, and I'm going to dive down this column. Now notice here I'm diving down this second column. Okay, this second column is going to go first row, second column in my answer. So 1 times 10, this is that 1 times that 10, plus 2 times 11, plus 3 times, oops, that's 11, sorry, 3 times 12. Now I'm going to do my bottom ones. Okay, so now I'm going to be figuring out the bottom row in this matrix. I'm going to run across this 4, 5, 6, and I'm going to dive down this first column. Okay, so as I'm running and diving, the 4 is going to multiply by the 7. They're both the first number as I'm running versus the diving. My 5 is going to multiply by the 8. And then my 6 is going to multiply by the 9. And then one last one, and these are going to be an awful color combination. I'm going to run, and I'm going to dive down this one. So 4 times 10, plus 5 times 11, plus 6 times 12. And so the end result here, I'm going to have 7 plus 16 plus 27, 10 plus 22, 36, 28, 40 plus 4, 40 plus 55 plus 72. And now I'm just going to add all of those pieces up. So I have 50, 68, 122, and 167. And that's matrix multiplication. So let's try a 2 by 2. So the first thing I check is the dimensions. I have 2 rows by 2 columns, and then 2 rows by 2 columns. My middle pieces match. So the number of columns in this matrix match the number of rows in that matrix. And that makes sense, so that when I go to run and dive, I don't have something that doesn't have a piece to multiply by. My end answer is going to be a 2 by 2. All right, so I'm running across this one and diving down this one. So 0 times 6 plus 2 times 3. Then I'm going to run across this one and dive down this one. Okay, so I'll have 0 times negative 6 plus 2 times 0. Now I'm going to run across this one and dive down this one. That will give me negative 2 multiplied by positive 6 plus negative 5 multiplied by 3. Last but not least, we're going to run across. We're going to dive down. Negative 2 times negative 6 plus negative 5 times 0. So I end up with 0 plus 6, which will be 6. 0 plus 0, 0. Negative 12 plus negative 13, negative 27. And positive 12 plus 0, which is positive 12. But again, as you get to more complicated things, this becomes really tedious, and then using a calculator is very, very helpful. Okay. Ye Old Fashioned Ice Cream Shop. So the owners of Ye Old Fashioned Ice Cream Shop have a reputation in your community for producing the best tasting ice cream on earth. I know where mine is. So one of their secrets of their success is that they only use the fresh dairy ingredients, which they purchase daily. We're going to use the information given to help them decide how much they need to purchase daily. Okay, so here's the information they gave you. All of the ice cream at Ice Cream Shop is made from 2 basic recipes, to which various flavors, fruits, nuts, and candies are added to create the variety of tastes. That's wonderful to know, but I don't need it for my problem. One recipe is for their health-conscious customers and is called light, since it's less caloric than their extra rich recipe. A batch of light ice cream uses 1.5 dozen eggs, 2.5 gallons of cream, and 5.5 gallons of milk. A batch of extra rich ice cream uses 2 dozen eggs, 5 gallons of cream, and 3 gallons of milk. Both recipes require other ingredients such as sugar, but these ingredients keep well and are not purchased daily. The owners have collected data on how much ice cream they will sell. They have noticed that the demand for their ice cream is higher on weekends and holidays. This data helps them make decisions regarding how many batches of each recipe they will need to make on average on different days. That's nice, but you still haven't told me any of the information to create my matrix. They've decided on weekdays. Okay. They need to make, so on weekdays, they need 6 batches of light ice cream and 10 batches of extra rich. And on weekends, they need 6 of the light ice cream and 12 of extra rich. They found on holidays, let's get another color for my highlighter. I think the purple's gonna be too close. Let's do orange. On holidays, they need 8 batches of light ice cream and 15 of extra rich. Okay, so I'm going to actually use this information to make 2 matrices. One matrix is going to be from this first part, and it's based on the ingredients they need. One is going to be made off the batches. Got it? All right. So I'm going to call this matrix B for batches. I know. And I'm going to call this one R for recipe. Okay. So I'm going to do the recipe one first. The recipe. So I have two different ones. I have light and extra rich recipes. So okay, and my extra rich on that one. Okay, and the ingredients I have are eggs, cream, and milk. So, and I'm just labeling eggs, cream, and milk. Remember, when we're working with a word problem, it's not uncommon to put little labels on the side. It helps us keep track. So the light needs 1.5 dozen. I'm just writing in dozen because that's how they're probably purchasing it. 2.5 gallons of cream and 5.5 gallons of milk. Okay, my extra rich has 2 dozen eggs, 5 and 3. 2, 5, and 3. So that's my recipe one. Now my batches. Okay. Now, based on what we know about matrices, my number of my columns has to match my rows. Okay. So see how my columns are light and extra, light, batch, and extra rich. So those are going to be my rows in this one so that I will be able to multiply them. So then my columns here are going to be weekdays, weekends, and holidays. Okay, so on weekdays they need 6 batches of light and 10 batches of extra rich. Weekends they need 6 batches of light and 12 batches of extra rich. I guess people aren't worrying about the calories then. And on holidays they need 8 batches of light and 15 batches of rich. Okay. All right, so based on this information, I'm able to multiply R by B in that order. Okay, I can't. So as I go to do my run and dive, notice how my light eggs is multiplied by the number of batches of light I need on the weekends, and extra eggs, the extra rich, how many eggs in the extra rich is multiplied by extra rich. You just want to make sure that that's happening. So my result is going to be eggs so 1.5 multiplied by 6 plus 2 times 10. And when I do this, so this is all just determining how many eggs I need on each of the days. So on weekends, I have 1.5 multiplied by 6 plus 2 times 12. And then once more, I'm going to have 1.5 times 8 plus 2 times 8. And this is on holidays. And then cream, I have 2.5 times 6 times 10. And cream, 2.5 6 5 times 12. And cream 8 plus 5 15. Last but not least, milk. 5.5 6, 3 times 10, and then 0.5 times 6, that's 3 times 12, and 5 times 2 is 3. And you can kind of see as you're looking at these different pieces how your 6 is all right there, and that's from this 6. And how you have 10, 10, 10, that's from this 10. Okay. And if I go across instead, you can see 1.5, 1.5, 1.5, and that's from this 1.5 for the eggs. So this was eggs, cream, and milk. So I'm getting 9 plus 20, which is 29. Then 33, 2, 5, 75, 95, 63, 69, 89. So this is the amount of eggs that I need on a weekday, weekend, and holiday. So on a holiday, I'm going to need 42 dozen eggs. On a weekend, I'm going to need 75 gallons of cream. On a weekday, I'm going to need 65 gallons of cream. So again, this was just a way of organizing. Matrices here were used to organize it, keep track of all the pieces, and then I was able to figure out how much I would need. What would be even better, take it a step further, this problem didn't ask us to, but we could take it a step further and compare two different stores, their cost for different items, and then see which one had the better price overall based on day, weekend, or holiday. All right, so, but this was a lot of work to multiply all these out. And I did say I was going to show you how to do them in the calculator, and I will, don't worry, I haven't forgotten. So, take a look at this one first though. This is a 2 by 3 and by a 2 by 3. 3 and 2. So the number of columns I have in the first one with that 3 columns does not match my rows. Wah, wah, wah. So this, our product is undefined. You can see if I go to run and dive of 3 times 4, 2 times 5, and then 5 times nothing. There's why that's undefined. Okay, I'm going to do one more by hand, and then I'm going to show you how to do it on the calculator. So we're going to run and dive. And again, here I have a 2 by 2 multiplied by a 2 by 1. My 2's match. My answer is going to be a 2 by 1. Okay. So I'm going to have 5 times negative 4 plus 4 times 3. And then this one's going to be 2 times negative 4 plus negative 1 times 3. So I get negative 20 plus 12, negative 8 minus 3 for a negative 8. Alright, so let's take a look at that one. Even though we just did it by hand, let's take a look at how to do that one in the calculator. I'm going to just put it over to the side there. So I'm going to do back into my matrix window, which is second x to the negative 1. I'm going to edit matrix A and make it a 2 by 2. Notice it got rid of the extra column. And now I'm just going to type in what I have. I have a 5, a 4, a 2, and a negative 1. To put the negative, make sure you're using the negative sign, not the subtraction sign. That would give you an error. Okay. Double check, proofread it. Very important. And now back to that matrix window, second x to the negative 1. And I'm going to go edit B for a minute. And I want a 2 by 1. And so that was -4 and +3. So matrix A times B. And you can put them right next to each other like that. Oh, good, I got the right answer. Or I can even do it with a multiplication between them, and I'll still get the same thing. Okay? So depending on how big the matrix is and what kind of numbers I have in my matrix, that usually is what indicates whether I'm going to do it by hand or whether I'm going to do it in the calculator, because there's a lot of steps to typing it in the calculator. It's not hard, but there's a lot of room for error and careless types of errors. So, all right, let's take this one. Pause the video for a second, type it into your calculator, and try to find this product here. Got a chance? You did it? Okay. All right, so I'm going to my matrix. Look, I've got that first one in there. 5, 1, 1, 0, -3, -5. And boom, perfect. Okay, so I'm going to take my matrix A, multiply it by matrix B. Boom. Pretty snazzy, huh? Cool. So, are these two problems the same? If I had that A is 4, 2, -5, 3, and B was -1, 5, 5, 6, does it matter if I multiply A times B or B times A? Make a prediction, jot it down, hold yourself accountable for it, and now let's take a look. All right, so I'm going to my matrix. I've got A, 4, 2, -5, 3, and I've got B, -1, 5, 5, 6. It is really important to check. I know I sound like a broken record, but it is important to check that we're typing them incorrectly, because one small typo, you're going to get completely different answers, and it's one of those things you won't be able to determine why something's wrong. A times B is, so there's that, A times B. Now let's do B times A. So if I'm going to do B times A, I'm going to type in B first and multiply by A to see if this comes out the same. That's what we're investigating. Ooh, I don't want -1 there. Second -1. Ready? Drum roll. So were they the same? No. So this one came out as -29, 13, -10, and 28. And this one came out as 6, 32, 20, and -7. Now, are there some combinations of numbers that would magically come out the same? Yes. Okay. But as a rule, matrix multiplication is not commutative. You can't just switch the orders and get the same answer. Okay. You get different answers if you multiply in different orders. Boom. Not commutative. Yikes. So here's one. I have a 4 by 3 and a 3 by 2. My 3's match, so my product is defined, and I don't want to do it by hand. So pause the video and try that one with the calculator. All right, so I've got my matrix. I've got my ones in there. I have my 4 by 3. Double check the values, make sure there's no sign errors. And my 3 by 2. And now I'm going to multiply them. A times B. Boom. That's what it says. Way better than if I tried to do it by hand. Okay, now could I do it by hand? Yes, I have the ability to. And if it had variables in my entries, I would have to do it by hand. But here I didn't have any of that, so I just multiplied it with the calculator because it was large. All right, here's another one. You can use that to check your comprehension. All right, so second matrix. I have my 2 by 3, 5, 3, 5, 1, 5, 0. And I have my 3 by 2, 2, 4, 2, negative 3. Perfect. So I'm going to take this, multiply A by B. And what's interesting, I'm not asking for the reverse order on this, but if I did the reverse order, it'd be a 3 by 3 instead of a 2 by 2. So they wouldn't even give you the same size matrix to reverse them. Okay? All right. One last thing, another application problem. I'd like you to pause the video and try this one. A local shop sells 3 types of pies. Beef pot pies cost $3 each. I don't want to think about what the ingredients must be. Chicken pot pies cost $4 each. These are individual sizes too, not whole family. And vegetable pot pies cost $2 each. The number sold each day in a week is given by that lovely table. Write 2 matrices for this information, then find the product. What does the product tell us? So I'm going to first just make my first matrix literally this table. Okay? 13, 9, 7, 15. 8, 7, 4, 6, 6, 4, 0, 3. And I had my beef, chicken, and vegetable. And Monday, Tuesday, Wednesday, Thursday. Okay, I'll put my label on top. So my first one I pulled right from that table. If they give me a table, I'm always going to make that into my matrix because it's already pretty much a matrix anyway. Now, this one, I have a choice. I can either set it up as a 1 by 3. That's a 3 by 1. Or 1 by 3. Now, the question is, which order should I set it up as? This one is a 3 by 4. See how this first piece is a 3? That means I want to set up this matrix as a 1 by 3. So I'm going to have my money. I'm going to have beef, chicken, vegetables. And you want to make sure you're putting them in the same order. 3, 4, and 2. I wasn't very tricky. I had them already in that same order, but you want to just double check that you're not. Because you wouldn't want to take the cost of beef pies and multiply it by the number of chicken pies sold. That wouldn't make any sense. Okay? So as I run and dive, I need to make sure beef is multiplying by beef, chicken is multiplying by chicken, veggie is multiplying by veggie, things like that. Okay? So our product is going to be 3 times 13 plus 4 times 8 plus 2 times 6. And the next one I'm going to run and dive again. I'm doing this by hand just because I want to type into the calculator. 3 times 9 plus 4 times 7 plus 2 times. And then run and dive. And move everything over because I'm running out of space already. Advantage of technology. 3 times 7, 4 times 4, plus 2 times 0. Nobody wanted veggie ones that day. Okay. And last but not least. Okay. And that's 3 times 15, plus 4 times 6, plus 2 times 3. Well, so we're going to need money is what's left on that piece. So this one comes out as 83, 63, 37, slow day on Thursday, and 75. So this is telling me the total revenue by those 3 pies on each of those days. Monday, Tuesday, Wednesday, Thursday, and the amount of money. And that concludes our lesson on how to multiply matrices.